This video is talking about sequence and series. In the video, we are going to learn how to express a series using summation notation or sigma notation. In the video, we are going to learn how to change the long series here into a notation, and we call it as sigma notation. This symbol we call it as sigma. Since we are going to find the sum of the series, so these symbols, sometimes we also call it as summation notation. First, we are going to learn what are the important parts in a summation notation. First one is the general term of the series. Then followed by the index. Index is the variable in the series. We can use any alphabet to represent the variable. We can use R, we can use I, we can use X or some other variable. But most of the time we use R or I. Then one thing you must take note that you must make sure that the general term must be in terms of the index. For example, if I use I as the index, then the general term must be in terms of I. Then followed by the lower limit. Lower limit is the starting term of the series. And this is upper limit. Upper limit is the ending term of the series. If I want to find the sum of a series from the first term up to term number 10, then this is 1 and this is 10. If I want to find the sum from the term number 10 up to term number 100, then this value is 10 and this value is 100. Now let's try this question. Write the following series in summation notation. So to write the summation notation, first we need to find the general term of the series. The general term, also known as N term or R term. When we look at this series, we find that there are two things. First one is the change of the sign. It is from negative to positive alternately. Then second thing is the value change from 3 to 5 to 7 and so on. So to write the general term, we can separate into two parts. So first part is for the sign of each term. The second part is the value of each term. Now for the first part, actually the sign of each term depends on the power of negative 1. If the power of negative 1 is an odd number, then the value is negative. If the power of negative 1 is even number, then the value is positive. Then it is noticed that the power of the negative 1 change from 1 to 2 to 3 to 4 and so on. So actually this is an arithmetic progression. So we can use the formula Tn equals a plus n minus 1 times d to write the power of the negative 1. That is, a is 1, d is 1, so it is equal to n. Therefore, the first part of the general term, we can write it as negative 1 power n. Now for the second part, notice that the values of each term change from 3 to 5 to 7, 9 and so on. So it is an arithmetic progression. So same thing, we can use the formula that is a is 3 and d is 2. When simplified, then we get 2n plus 1. So therefore, the second part can be written as 2n plus 1. So now, this is the general term of the series. After we have got the general term, now the second step is write the series in sigma notation. When writing sigma notation, first thing is the general term. Notice that The general term is in terms of n. When writing the general term in the sigma notation, the variable depends on the index used. Here I use r as the index, so means the n in the general term in the step 1, now I have to change to r. That is, the general term is written in terms of r, same as the index that used. Now next step, I'm going to find the lower limit and upper limit, that is the starting term and the ending term of the series. To determine the lower limit, we try to compare the general term with the first term. Ignore the sign of the term. So, we compare 2r plus 1 with the first term 3. So, we find that r is equal to 1. So, means the first term starts from the first term. As for the upper limit, we try to compare the general term with the last term, that is 51. So we find that for the last term, r is equal to 25. So means the upper limit is 25. So therefore, this is the sigma notation for the series. Now we proceed to the second question. Compare with the first question. The first question, the first term is negative, the second term is positive. But now in this question number 2, the first term is positive, the second term is negative. So when writing the general term, same thing, we divide into two parts. One is for the sign of the term, one is for the values of the term. So when we look at the power of the negative one, since the first term is a positive value, means the power of the negative one, we need an even number. So followed by the second value is a negative number. So the power of the negative, we need an odd number. So therefore, the change of the power of negative is start from 2 to 3 to 4, 5, 6 and so on. So this is also an arithmetic progression, but the first term is 2. So means that is n plus 1. So therefore, the first part of the general term is negative 1 power n plus 1. As for the second part, it is same as the first question. That is, the arithmetic progression start from 3 and we get 2n plus 1. So the second part is 2n plus 1, same as question 1. So this is the general term for this series. Now after we have got the general term, now we try to write in sigma notation. When writing sigma notation, if the index is x, now I have to change the n into x, same as the index. Then after that, I'm going to determine the lower limit, that is the starting term. So now I'm going to compare the general term with the first term, ignore the sign of the term. Now I compare 2x plus 1 equals the first term 3, so means I get x is equal to 1. As for the upper limit, when we look at the series, this is an infinity series. So means for the upper limit, we are going to use the infinity as the upper limit. So now we get the summation notation of this series. Now we proceed to the third question. When writing the summation notation, first we need to find the general term. Notice that all the terms in the series are in the fraction form except the first term. So means I'm going to change the first term in fraction form. Then when writing the general term, I can divide into two parts. First part is the numerator, the second part is the denominator. For the numerator, notice that the number changed from 2 to 4, 6, 8 and so on. So this is an AP. So by using the formula of AP with the first term is 2, now I get 2n. So means the general term for the numerator part, I can use 2n. As for the denominator, the number change from 1 to 3 to 9, 27 and so on. So it is noticed that this is an GP. So I'm going to use the formula of GP, where A is 1 and R is the common ratio, that is 3. So it becomes 3 power n minus 1. So for the denominator, it is 3 power n minus 1. So this is the general term of this series. After we have got the general term, now we are going to write this series in sigma notation. So since I'm using the I as the index, so the n just now in the general term, I change to I. That is same as the index. So next I'm going to determine the lower limit. Now to determine the lower limit, I only need to compare either numerator or denominator because they are the different progression. Since the numerator is an AP, it is easier in calculation. So I compare the numerator where 2i compare with the first term. First term, the numerator is 2. So I is equal to 1. So means the lower limit start from 1. Now as the upper limit, since the series is an infinite series, so means we just use an infinity to represent the upper limit. Therefore, the sigma notation for this series is this one. Now we proceed to question number 4. When writing the summation notation of this series, first we are going to determine the general term. When writing the general term, same thing, we can see that there are two different parts. One is for the numerator, one is for the denominator. When we look at the numerator, we find that all the numerator is equal to 1. That is a constant, not a variable. So therefore, the general term for the numerator part, also we write down the constant. Then as for the denominator, we find that the number change from 2 to 3, 4 and 5. So it is an AP. So we are using the formula for AP where A start from 2. Now we get n plus 1. So therefore the numerator is n plus 1. So this is the general term for this series. Then we proceed to second step, that is writing the sigma notation. Since we are using the R as the index, so the n here we must change to R. Then next we are going to determine the lower limit. Now here to determine the lower limit, I just compare the denominator of the general term with the denominator of the first term because the numerator is a constant. So when I compare R plus 1 equals 2 means R is 1. So the lower limit starts from 1. As for the upper limit, I compare the R plus 1 with 50. That is, I compare the denominator. So means R is equal to 49. So therefore, the summation notation for this series is the sum of the series from term number 1 up to term number 49. However, the summation notation of a series sometimes can be more than 1. For example, the same question. For the general term, same thing, we divide into two parts. One is numerator, one is denominator. The numerator, definitely it is equal to 1 because it is a constant. For the denominator, just now in the example just now, I use n plus 1. If I don't use n plus 1, when I look at the number simply change from 2 to 3 to 4 to 5. So I can simply use n to represent the change of the number. The only difference is when we write the upper limit and lower limit in sigma notation. For the lower limit, I simply compare the denominator of the general term with the denominator of the first term. I find that x is equal to 2. For the upper limit, I compare the denominator of the general term with denominator of the last term. I find that x is 50. So the sigma notation becomes sum of 1 over x, where x start from 2 up to 50. Compare with the answer just now. If I use x plus 1, then the lower limit start from 1 up to 49. Now we proceed to the next question. For this series, when writing the summation notation, first thing, we are going to find the general term. When writing the general term, the numerator part is the same. So it is a constant, so we follow the constant given. But for the denominator, there are two parts. First part is the change of value for the first number, and the second part is the change of value for the second number. Now for the first number, notice that the first number changed from 3 to 5 to 7 and so on. So notice that this is an AP. So by using the formula of an AP, start from 3, then we get 2n plus 1. So means the first part, we can use 2n plus 1. For the second part, the value changed from 5 to 7 to 9. So this is also an AP. So by using the formula an AP with the first value is 5, then we get 2n plus 3. So means here we can use 2n plus 3. So this is the general term of this series. So next, to write the sigma notation, we need to find the lower limit and upper limit. Now to find the lower limit, since you have two parts, so we simply choose one of the factor to do the comparison. So now I decide to use 2r plus 1 to compare with the first number 3. Now r is equal to 1. And for the upper limit, since this is an infinity series, so I simply use an infinity to represent the upper limit. So therefore, the sigma notation is this one. Now next example. In this series, the general term is already given. If the general term is already given, then we have to use the general term given. Then, when writing the sigma notation, we only need to determine the lower limit and upper limit. Now, to determine the lower limit, we simply compare the denominator of the general term with the denominator of the first term. So we find that r is equal to 2. As for the upper limit, we compare the denominator of the general term with the denominator of the last term. We find that r is equal to n. So therefore, the sigma notation for this series is started from r equals to 2 up to n. Now we proceed to the next series. To write the summation notation of this series, first thing we must write the general term. When writing the general term, let's look at the numerator part. For the numerator, here we have an x here. X, even though that is an alphabet, but the x does not change from term to term. Means even though x is an alphabet, but since it doesn't change from term to term, so we consider x is a constant. But when we look at the power will change from 3 to 5 to 7 and so on. So means the power is a variable. So change from 3 to 5 to 7 with a is 3. Now we get 2n plus 1. So the power we can use 2n plus 1. Now as for the denominator, the value change from 2 to 3, 4 and 5 and so on. So it is also an AP. By using the formula A start from 2, now we get n plus 1. So the denominator is n plus 1. So next we are going to write the sigma notation. We are going to find the lower limit. To find the lower limit, we just compare the denominator of the general term with the denominator of the first term. Now we get r is 1. For the upper limit, same thing, we compare the denominator of the last term with the general term. So we get r is 99. So therefore, the sigma notation of this series is the sum of first term up to term number 99. Now we have come to the end of the lesson. From the lesson just now, you have learned that when writing a series by using summation notation, first we must know the general term. And secondly, we must determine the upper limit and the lower limit of the series. And one thing you must remember that the variable in the general term must be same as the index of the summation notation. To master this topic, you must keep on practicing. If you have any question, let me know in Teacher Eileen Maths group. I hope to see you soon. Bye.